Hey YouTubers. Okay, I know I haven't put out a video for a while now. Okay, I've been a little bit busy. Life just happened. Well, one thing is, I'm not going to put out videos that I don't find have any relevance or substantial information. But you know, and sometimes it's not all the time that I see something that is important enough to share information on. But this I do find relevant, and this has been percolating in the back of my mind on a subconscious level, and it kind of rised up to the top, and I thought this would be a good time to share this. So what I'm going to be sharing is I'm going to explain a little bit better coil shorting on a generator coil, and what is exactly happening inside of this coil, generator coil. I'm going to probably divide this up into a series of videos because it's a lot of information and it's not hard to understand, but I'm going to attempt to explain this in layman's terms that anybody can understand. But so first of all, you know, originally I thought that there was a collapsing magnetic field coming out of this from the magnetic field formed from Lenz's Law when you load it down, and that loads down the rotor and everything. But so that's what I'm going to be explaining a little bit here now. So what I've done is this is a solid state AC switch that I made. It's basically just two MOSFETs or transistors, whichever you want to use. That's back to back, and so it's pretty simple, self-explanatory. It's basically the same setup as usual. We got a coil. Each side of the coil is going to the AC side of this full wave bridge rectifier, and also each side of that coil is going to our collectors or gates or whatever. I don't try to remember these different component parts, but you know, if they're transistors, it goes to the collectors. And since this is an AC switch, this allows the AC that's alternating back and forth from the generated power to flow back and forth in this switch. And it's run by a 555 timer circuit here, and I'm running that with a 12 volt battery. Now, this battery is going to have really nothing to do with the effects that I'm about to show you. And so this is kind of like going to replace what a reed switch would do automatically for me. It's not perfect, but it's the only disadvantage here is that it's not perfectly synced up and timed out with the voltage peaks here when the magnet is the closest to the coil on either side, which is where you're supposed to switch it really fast. And so this is what that's going to do for us. It's not going to be lined up perfectly, but it's going to, you know, it will catch it every once in a while, and it does an okay job for our demonstration purposes. Also, I kind of like to use a radio on a low AM station. Turn it up, and you can hear and this helps me hear the I don't know if you can hear this or not, but that helps me hear the frequency of our and so this is the frequency it's set at to short our coil at, and it does a pretty good job. So here I have this capacitor shorted out, and in another video I'm going to explain how you have to have a capacitor for this energy to go into, because you're not going to be able to take a meter and read the current flowing into a battery. And I'll explain that reason later, but so for right now we need the capacitor. You can see it in the form of the voltage. So I got it shorted on 0, and so I came up with a way, I devised a way to get an okay measurement. And what we're going to be doing is comparing the difference between normal generated power and then the power you get from shorting. So we got this shorted out on 0, and now I try to get this set up automatically, mechanically, so we can try to reproduce this effect, and so it's the same each and every time. I cracked this glass and it formed a bubble right here, and so we're going to use that bubble as a reference point. Okay, and what we're going to do is we're going to pull this, so we're not going to be putting in any of our own energy into the system. We're just going to let this do it by itself. So when we release it, it just goes like this, and I'm going to stop it right there. So what's happening is this magnet right here is going to naturally attract to this right here, and then I'm going to stop it right here. So it's only one magnet pass. So we can see what's happening with just one magnet pass. Okay, so I'm going to take this short off, and it stays on 0. It's a little bit of a rebound effect probably, but yeah, see, and I had that shorted all night, but it's okay, it's not a lot. So this is what we're going to do. We're going to start right now, and we're just going to start it right here, and this is kind of hard to do with one hand, but it's basically still on 0, and I'm just going to let it go like this. I'm going to stop it, and you see we got about 400 millivolts. Okay, so that's how much it normally would generate with just one magnet pass naturally. So we're going to short that out again, take the short off. I'm going to do this a couple times, so I'll pull it down about right here. I put like 1 millivolt in there, but it's kind of hard to do, like I said, with two hands. So I'm going to let it go, stop it right here. See, we got about 340 millivolts. Okay, let's do it again. And this is so we can see roughly what it's generating. So we're kind of like creating a, I know it's not the most accurate way to measure something, but if you don't have expensive equipment and oscilloscopes to see this better, this is probably the next best thing you can do. I know it's not extremely accurate, but I mean, all we have now is logic to work with here. Okay, so I'm going to do this again. Take the short off. I'm going to pull this down a little bit, as slow as we can. Okay, I'm going to let it go. I'm going to stop it right here. So see, about 456 millivolts. So let's do it one more time to make sure. So you see it's roughly 400 and something millivolts. And so that's what we're generating normally. This is all the available generated power going into our capacitor. Okay, the capacitor being a load. Okay, so we got it here. I'll let it go. Stop it right here. So see, almost like 500 millivolts. So somewhere between 400 and 500 millivolts. If I had my camera being held by something, I could do that a lot more accurately. But anyways, so I'm shorting it again. Okay, now we're going to turn on our switch, our AC switch. So that's going. That's running. Alright, now we're going to take the short off, and we're going to do the exact same thing. We're going to pull this down a little bit. This is where it's starting. See, just pulling that down just already put 114 in there, but it's what we were doing before. So we'll let it go. Stop it. Now look. See that? It's 1.20 volts. Basically, another like 600-700 millivolts was added onto that. So let's do this again. And this is the smallest scale I could possibly do, I think. So we short it out to 0. And you know, if I could put this camera down, I would be able to like start it like this, but I can't. So every time I pull it down, it's actually generating. But we can include that. It's okay. I'm going to take the short off. Okay. I'm going to pull this down. And just doing that, see, I already put that in there. Okay, so we're going to let this go. Stop it right here. And see, we got our 1.20 volts. When before, it was, you know, like 500 millivolts. So we more than doubled our voltage going into our capacitor. Now, another thing is why we're doing this is creating like the same time period. And time is an important thing to look at because current is related directly with time. You see, it takes time for current to flow. So, you know, even if it was a high voltage that we were generating, and let's say the current was lower, well, then the voltage would be equal to or less than what we would normally be generating. But if the current and voltage is higher, then if we, you know, charge our capacitor up with that higher voltage and current, then we're going to get a higher voltage because there's going to be more current flowing to meet that higher voltage than what we normally generate. I hope that makes sense. It's kind of hard to explain, but I mean, if you have more current and more voltage, you're going to charge this capacitor up to a higher voltage in the same amount of time, or less. So there's obviously more current and voltage that is coming out of our generator coil. I'm going to show you a picture. I'm going to try to insert a photo, like right here. Okay, I think that's long enough. So you can see this. If you look, you know, there's I might have to make another video for that to explain that picture, but in that picture we see that our power we're getting at the peaks of our sine wave is like we're not even using our AC wave that we're generating. We're not even using our generator power. We're getting another power out of just a tiny little section of our normal AC wave coming from our magnets. And I will explain that in another video because there's just not enough time for me right now. But we'll do this again without our coil shorting, and we'll short this out again to 0. And this time we're going to do it a little bit faster so you can see. And what I'm going to do, I'm just going to give this one quick spin, and then I'm going to stop it. So it takes roughly about a second. Okay, so we can see what we normally generate within just 1 second. Okay, so here we go, right here. Spin it, stop it. So we got about 16 volts there, 16.5 volts. That's what it would normally generate. So I'm shorting it out. We're going to do it again so you can see what we normally generate. So let's take this out. Let's make sure this gets shorted nice and good to 0. And while it does that, I'm going to take a sip of coffee. Coffee is so good in the morning. Sorry about the lighting in here. I use the outside light for lighting, and it's morning time. So okay, that's long enough. Let's take this short off. Okay, spin it one more time, really good. Stop it. Took about a second, right? So see, that's about 16, 17 volts is what we're generating. And, you know, it's just generated power. It's all the power available from our rotating magnetic fields of our rotor. Now, we're going to turn this on, this thing, and I'm going to also try to, like, hopefully, you know, provide a link to an image you can download for the schematic of this. I'll try to post it down below if I have time. I'll really try to work on that. I'm sorry if I haven't done that before, but so we've got it shorted still at 0. Okay, take the short off. Now watch this. I'm going to do the exact same thing in the same amount of time, and look, we got a higher voltage. So there had to have been a higher voltage and a higher current flowing into this capacitor. And just for good measure, we'll do it again. Take another sip of coffee here. I like to get this to where it says -1. That tells me that it's, see, like that. That's nice and discharged. And another thing is, when you get this higher voltage into this capacitor, you got more joules. And if you have more joules, you can discharge, obviously, more power in the form of wattage. So there is more wattage coming out of this thing. And it's not as simple as just a collapsing field. There's an actual ringing going on inside. It's another AC that's superimposed upon the AC that this generates that we're not really using. It's incredible. It's pretty exciting to me, actually. And because, you know, and again, I'm going to have to make another video ranting about how we are still using oil. Oil. We're so lubed up with oil, it's not even funny, and we need to get off of that. But anyways, here we go. Let's take this off. Okay, spin it up one more good time. Stop it, and I'm even stopping it faster so there's less time. And look at that. 26 volts. Yes, I might have spun it a little bit faster, but I mean, you get the point. You see what is possible. We'll even spin it, you know. Well, anyways, you get the point. Even if we let it self-oscillate, let's go ahead. I think I got time, maybe, to do that too. Is to let it self-oscillate by its. Now, I'll make another video for that. But if you just like start at a certain point like that and just like let it self-oscillate back and forth like that, it'll actually, you know, naturally, without me putting much of my own input energy into this. See that it's going back and forth, and got it shorted so you won't see it right now, but you could see a major difference between just what we normally generate, and then by shorting our coil out, shorting that generated power at a certain point. But anyways, I hope that explains it a little bit better, and I think it was important enough to record and to explain a little bit better. And like I said, I think I'm going to make this into a series. I'll provide the links to the photo of the oscilloscope shot of what's going on inside of this coil. It's very amazing. So if you're new to my channel, please subscribe, and thanks for watching, and try to share this, because I think it's very important. But I'll see you on the next video.